Okay, so we are going to look at these sine and cosine graphs. Again, this is going on page 100. We built them over the last couple days and looked at yesterday how the unit circle unrolled to give us this. So I'm going to say once again, for the unit circle, the x value is the cosine of theta, the y value is the sine of theta. But if it's not the unit circle, that is not the case. And these are not circles, not the unit circle. All the information comes from that, but again, it's not just a straight translation like that. So f of x equals sine of x, f of x equals cosine x. So just like any function you've ever had, x is your input, this is your output. X is your input, this is your output. So the only thing you've ever been able to take the sine or cosine of is an angle. So x has to be an angle. So this could also be f of theta equals sine theta, same thing. So my input is an angle. My output for this one is the sine of that angle. My output for this one is the cosine of the angle. Okay, so cosine is a y value for the cosine graph. So it says, notice that the cosine function is a horizontal translation of the sine function. And I showed you that yesterday. Actually, on the board, it's still translated over so that they're kind of stacked on top of each other and look the same. But it is just a translation. So any transformation of a sine function is called a sinusoid. Therefore, sine and cosine functions are called sinusoidal functions. Okay, sine waves, sound waves, they're all sine waves. Okay. So functions that repeat at regular intervals are called periodic functions. So we will have periodic functions that are not sinusoidal functions, but these two are sinusoids. Okay. Period and amplitude. We talked about those yesterday, but we didn't write them down anywhere. So the period is the length of one cycle. And it can start at any x value on the graph. Okay, so it's the length of one cycle, and it can start at any x value. Most of the time we're looking, well, for the parent function anyway, we start at 0 and then how far do we go, just because it's easier to look at, but it really could be anywhere. So when we look back up here at these sine and cosine, right, so one cycle, if I start here, one cycle gets me to 2 pi, that means the period is 2 pi. But I could start here, the cycle starts here, and that's still the length of 2 pi, so either way. Okay. So this is the period. And then here, again, we look at it, it's starting at 0, going to here before it repeats. But I could if I want to look at it the same way I look at sine, I could say I start here and end here. That length is still 2 pi. Doesn't matter. It's just like it's a little easier to count here. So this is one period. For amplitude, yesterday I think I said, I'm not sure if I said the same thing in every class, but for the parent function, and it's true for the parent function, that the amplitude is the distance from the axis to the maximum or the minimum. But sometimes we have translations up and down. If I translate up and down, then that's not really, you can't go from the x-axis. For the parent function, that's a true statement, but we need to generalize it here. Just trying to get the information out quick to you yesterday. So amplitude for any sine or cosine function is half the distance between max and min values. Okay. Which means that since this is a parent function, it is the distance from there to there, but this is the amplitude. And even I could do it down here, it's still the amplitude. Any questions at this point? It's all kind of a repeat from yesterday. Yes. Yes, yeah. So like even, yes, because whenever we stretch it, it'll be like a uniform stretch, I guess. So if this amplitude gets, if this side gets bigger, this side's going to have to get bigger as well. So yeah, it'll always be symmetric. All right, so let's look at this here. So it says given f of x equals a times sine of bx, or f of x equals a times cosine of bx. So I want you to look at those, and I want you to just kind of ignore the sine and cosine part of that. I want you to think about what you already know about transformations. We have done transformations a ton, right? So I don't want you to think it's any different or that much more crazy or confusing because it's trig. That a that is multiplied out front of both of those, what does that and has it always done for our graphs? Vertical stretch or compression, right? That a multiplied out front is a vertical stretch or compression. Do we all agree with that? Still a vertical stretch or compression. We just don't call it that for trig graphs because they have other properties, but it's still technically what's happening. Because your amplitude, like if a isn't there, then it's just 1, right? We just don't write the 1. So your amplitude is 1 for the parent function. If a is 2, well, my amplitude is now 2, right? We just don't put vertical stretch or compression. We call it the amplitude. If there's a negative out front, it has nothing to do with the amplitude. If there's a negative out in front of the a, what does that do? Reflect in the x-axis, exactly. So that means the amplitude, positive or negative, that doesn't matter. We just want the positive version of that, so it's the absolute value of a. Okay, so again, the b that's multiplied by the x. In every transformation you've ever done, what does that number do? Horizontal stretch and compression. When you multiply a number times the x, that's a horizontal stretch or compression, right? And x lies. X still lies, okay? So if that b is 2, then what actually happens to my graph horizontally? It's a compression, right? So we get, like, if my graph is stretched out like this, it's going to get cut, not cut in half, but it gets squished, right? So the same thing happens here, but we talk about it as the period. If the period is 2 pi, right, for the parent function, then if b is 2, what's the period? Pi, because we divide it by 2. Does that make sense? We divide it by whatever b is. So the period for all of these sine and cosines are going to be 2 pi divided by the absolute value of b. B still does the same thing, but we don't have that period in any other graph we have done, so we just cut whatever the distance is in half and count it that way. So we're going to look at it a little differently. But I just want you to see that they're still doing the same things. Okay, that's their purpose in the functions haven't changed. We just have names for them here. Okay, so on these we are going to identify the amplitude and the period of each function. So on number 1, what is the amplitude? 1, right? There's not a number in front of sine, so my amplitude is 1. The period, what is the period? Exactly. And I would highly suggest for a while that you actually write it out. It's 2 pi divided by that number, which gives you pi halves. That is the period. Okay? So yes, the period gets multiplied by 1/4 basically, but that gives you pi halves there. Right? So number 2, what's the amplitude? 7/2, good. And what's the period? 2 pi, because there's nothing there, right? Number 3, what's the amplitude? 5, and it's a positive 5. That negative does what? Reflects in the x-axis. Okay, they didn't ask me that here, but it does something. Okay, so then the period, yes, because we would get 2 pi divided by 1/3, and that gives you 6 pi. Okay. Okay. All right, so you do number 4 on your own. All right, what's the amplitude? Amplitude is 2. That negative will reflect it. What is the period? 3 pi halves. Any question about how we get 3 pi halves? We're all good? All right. Flip it over. Graphing these is not complicated at all if you do what I tell you to do, okay? And I know some of y'all are super hard-headed and you don't think it's necessary, and it may not be necessary for you on a couple of these graphs, but these are going to get more involved, I promise you. This doesn't have any translations or anything in it yet, and once it does, if you are not following the steps I'm telling you to, you're going to get yourself confused, and then when you ask me for help, I'm going to say, where's this, and I'm going to force you through that process, where if you'd have done it yourself for the first time, you probably would have gotten it all figured out. Turn that off, please. All right, so let's look at number 5. The first thing I want to do is identify the amplitude and the period. So what is the amplitude here? 2. And what's the period? 2 pi. Okay. So then, what I want you to do, and what is necessary to make sure you get the correct points everywhere, is we're going to draw a little sketch of one period of the parent function. Okay, so here, it's going to look like sine. Sine, I know, looks like this, right? And then I have these 5 anchor points. That's what's going to help me get this graphed, okay? So for the sine for the parent function, I start at 0, 0. Since we're not translating left, right, up, or down right now, I'm going to start at 0, 0. So I've taken care of this point. So the next thing I do is find the end of the period. The period is 2 pi. It's going to be another 0. I know that for sure because I'm looking at my parent function up there. Boom. Then that takes care of this one. Then halfway in between is that third 0. Takes care of that one. Halfway in between these two zeros is my maximum, which for the parent function is 1, but what is it for this one? 2. And then halfway in between here, it's negative 2. Once you have your 5 anchor points on there, you should be able to repeat the pattern for the rest of the graph. Right? So I have it as a 0 at every pi, so I can put these in here. And your maximums and minimums just alternate because of the nature of the graph. And then when you sketch it in, you have to actually hit the points. Last period there was somebody that they just slopped something on there. This is not an art class, but it has to at least look like a decent graph. And there are arrows on the end because it continues. You don't put those arrows, I'm going to take points off or count it wrong because you're saying that your graph stops and it doesn't stop. Okay? What questions do you have right now? We good? So again, I know some of you are already thinking, I didn't need to have that little drawing up there. I totally could have done that. You're going to need this on some of them. Trust me. All right, so number 6, what's the amplitude? 5. What's the period? 4 pi. Okay? So I'm going to draw myself a little. So this is cosine. So it's going to look like this. And then here are my 5 anchor points. Here I have 2 zeros and then 3 maximum ends. So for my cosine parent function, I start at 0, 1, but I'm not going to be at 0, 1. I'm going to be at 0, what? 5. So I'm going to put the point there. So I've taken care of that point. So now I'm going to find the end of the period. The period is 4 pi. Well, 4 pi is way off my graph. So I can't even do that one. Just fine. So it's way over here somewhere. But then halfway between 0 and 4 pi, I have a minimum. Well, that's at 2 pi. So 2 pi is going to be my minimum, which is at what? Negative 5. Okay? And so I have the minimum done. This point halfway, it's off my graph too, so I can't do that one. But I can go halfway between 0 and 2 pi at pi, and what do I put there? A 0. So I can only get 3 of my 5 anchor points on the graph, which is fine. That's enough for me. I mean, that's all I can do on the right-hand side anyway, and then I can continue the pattern over to the left. So if this is my maximum, this is a minimum, then my other minimum is over here, and my other 0 is at negative pi. And then I can sketch in my graph with arrows. What questions do you have? We all good so far? It's a process, and if you go through those same steps, it's going to just be a piece of cake, even when we start getting crazier looking equations. All right, let's look at number 7. What is my amplitude on number 7? 3/2, 3/2. But there's a negative here that's still important. What does that do? Reflects. It's going to reflect in what? In the x-axis, okay? What is the period? Pi halves, because it's going to be 2 pi over 4, right? And that is pi halves. Okay. So then draw my little graph here. And here are my 5 anchor points. Right. So 0, 1 is my parent function, but my amplitude is 3/2, so it's really 0, 1.5, right? But what else do I need to do? Reflect in the x-axis. So instead of 0, 1.5, I'm actually at 0, negative 1.5. That's why if you don't write it down or circle it or do something, you're going to forget to do it. I mean, you just are. So I'm here. Right? So now I've got this one, which was a maximum. Now it's a minimum. Totally fine. The period is pi halves, so I need to go to the end of the period to get the other point, which will now be another minimum. So at pi halves, I'm right here. And by the way, this is 0, this is pi. So this is pi halves. What is this right here? Pi fourths. Okay, that's important to think about as you think about what's on the axis there. All right, so now I have the beginning and the end. So halfway in between these two at pi fourths, I'm going to have a maximum of 1.5. So now I have this one. So then halfway in between these two, which would actually be like pi eighths, that's where my 0 is going to be. And halfway in between these two, I'm at pi eighths, and I'm right there. Because the 0 is halfway in between these two, and this is at pi fourths. So now I have enough to repeat. Well, clearly my 0 is in every space, right? So I can just go ahead and fill all those in. And then your maximums and minimums just alternate. Now, once you start to draw it in, you can usually tell if you've missed something. That's what it should look like. What questions do you have? So if I don't give you enough time to make your graph perfect and beautiful like you want it, at least get part of it drawn in. You can always go back and be extra about it if you want, but I'm moving on. All right, amplitude on number 8. What's the amplitude? 1. Reflect over the x. Very good. Put a little x there. And then what is the period? Yes, so it's 2 pi over 8. Ooh, it's on my pen here. 2 pi over 8/3, and that's what? 3 pi over 4. Okay, so this is what I'm actually using here. I'm drawing my little graph here. This is sine, so it's going to look like this. And, you know, eventually, you may not have to put all the 5 little points on there, but you still want to have that little sketch there with the axis. That axis is important. So that you can keep everything right. Just trust me on that. All right, so I have sine, so I'm starting at 0, 0, no matter what. The period for this is 3 pi fourths. Okay, so is that pretty easy to find on my x-axis? Yes, because each space is pi fourths, right? So this is 3 pi fourths. I end up right there. What's halfway between 0 and 3 pi fourths? 3 pi eighths, right? You just multiply with it. So 3 pi eighths, but that's here. I mean, you can also just tell by the spaces is halfway, right? Okay. So then I need my, so I haven't had to worry about the reflection yet because it's, because of the zeros, yeah. So, but I do have that reflection I don't want to forget about. And I have an amplitude of 1. So between these two, halfway in between, instead of being at 1, I'm going to be at -1, okay? But I need to think about where that's going to be. As far as it being, it will be 3 pi 16ths, but does that really help me find it on there? Yeah, no, it doesn't really help me find it on there, right? So, but if I think about this as far as, like, let's pretend that this is we're counting by ones on the x-axis. Halfway between 1 and 1.5 is what? 0.75. So you can think about like 3/4 of the way. You see how that makes it make more sense to you about like where to put it? So halfway in between will be about 3/4 of the way down. And instead of at 1, I'm at -1. And then halfway between these two is about 3/4 going this direction. And so it's up here. Just kind of hugging the line on either side. So when you're doing ones like this, you got to be a little bit more careful when you're doing the pattern. Now, the pattern for the zeros, I have my 5 points on there, so I'm good. And the rest is just finishing up all the pattern. For the zeros, it's easy. It's, every 1.5 spaces. So you're like on the line in the middle, on the line in the middle. And then when you alternate, make sure that you are going next to the line that you're supposed to be. And you on all of these, you have to go all the way to the end. If you can put a point on that last, you have to do that. You can't just leave it off because you think you're done. You need to make sure you think through whether or not you're actually done. What questions do you have right now? We good? All right, let's look at number 9. What is my amplitude? 5/2. And I have a reflection in the x, right? What is the period? 3 pi. Okay, so, and this is cosine, so my graph looks like this. Those are my 5 points that I need. So cosine normally starts, well, for the parent function, it's at 0, 1. However, my amplitude is 5/2, so it's really 0, 2.5. But what? I got to reflect in the x-axis. So instead of being at 0, 2.5, I'm at 0, -2.5. So I have this point done, was a maximum, but now it's really a minimum because of the reflection. Then I need to go to the end of the period, which is at 3 pi, which is off my graph. So I can't do that one. So I'm going to go halfway. What's halfway between 0 and 3 pi? 3 pi over 2, right? Do you know where that is on your x-axis? You should, yeah, because if you think about, you have 0, pi halves, pi, 3 pi halves, 2 pi. It's just like going around the circle. So this is 3 pi halves. Was a minimum, so it'll be a maximum at 2.5. So what's half of 3 pi halves? 3 pi fourths. Can you find 3 pi fourths on here? Yep, because they're each a fourth. So 3 pi fourths is a 0. So can I put another 0 to the right of this maximum? Yes, because this is, I've got my minimum, and then 1, 2, 3 is my 0. 1, 2, 3 is my maximum. 1, 2, 3 would be another 0. So I have to actually put it there if I can put it there. So now that I have that, just basically reflect it over here. Here are my zeros. and then my zeros, or I'm sorry, my maximum is up here. Okay. What questions do you have? Anything? Does it make sense? Understand how to process through it? All right, so you do number 10. Once you show me that you have it correct, then I will give you your assignment. So not an art class, but not pointy, curvy. I mean, I know mine kind of points, but it's not like a zigzag. So that's what mine looks like. What a lot of you missed that I had to go back and tell you to do were these points are right here. So make sure that you are actually going the full length of the axis that you have and you're not cheating the graph anywhere, okay?